Okay, I want to talk about one more type of probability problem you might see in this section that will save you a lot of time, actually. So let's talk about the same things here we did before, P, Q, N, and R, just define our variables here. And we're going to find something interesting. So probability of success, we want it to be defective. What's the probability effective? 0.5%. So that's actually 0.005 is 0.5%. Notice that's a percent, not 0.5. So failure would be 0.995. Those have to add up to 1. N is the number of bulbs that are tested. In this case, there are 6 trials, 6, so not 100, but 6. So 6 is N. Then R is the number that we want to be defective. Now here's what's weird about this. We really, we want 1 or more. So I'd be happy with 1, so R could be 1. I'd be happy with 2, 3, 4, 5, or 6. So here's the problem. I would have to do binomial theorem 1, 2, 3, 4, 5, 6 times, add those all up to get the probability of 1 or more bulbs being defective. Well, I don't love thinking about, you know, doing binomial theorem 6 times and adding it up. That doesn't sound like fun to me. There's only one other possibility, right? What's the opposite of 1 or more? So if you think about it that way, the R value of the opposite of this, well, I've got 1, 2, 3, 4, 5, 6. Are there any other possibilities? R equals 0 is the only other possibility. So if you do 1 minus the probability of R being equal to 0, you'll get the answer. Because all of these, 1, 2, 3, 4, 5, 6, and 0, if you add up all those probabilities, it'll add up to 100%. So it'd be 1 minus that. So 1 minus, then you would just use NCR, what is it? NCR, so 6, choose 0 times R, which is or P 0.005 to the R, which is 0, times 0.995 to the N minus R, which is 6 minus 0. So if you type that in your calculator, you'll get the right answer. It's just a lot faster. Let's look at one more to make sure we know what we're talking about here. So again, this is the complement of an event. All events have to add up to 100% here. So in this case, let's set up our variables, P, Q, N, and R. 5, R defective. We want defective, so that's again 0.005, so that's still that. 0.995 is failure, which is actually not defective. And there are 6 trials. And I want at most 5. So I want R to be 0, 1, 2, 3, 4, or 5. I'm actually happy with any of those. So I could do the binomial theorem 6 times, add up all those different probabilities and get my answer. Or 1 minus probability that, in this case, what's the only other case? The opposite of is R equals, let's see, 1, 2, 3, 4, 5, 6. So the probability that R equals 0 here. And then I would just plug that into the formula. So 1 minus NCR, that would be 6, choose 6 times 0.005 to the 6th times 0.995 to the 6 minus 6, which is 0. Type that in your calculator, you get the answer much faster. Or you could do the binomial theorem 1, 2, 3, 4, 5, 6 times, add up all those probabilities, and you'll get the correct answer. This is called the complement of an event.